All right, here we go. This is Unit 2, Lesson 1, under construction. Ready, set, let's go. Okay, so using a compass, construct several concentric circles that have point A as a center and a radius larger than half of the segment. Okay, that's important. So I'm going to make sure I'm just more than half of the segment, and I'm going to make some concentric circles. All right, so here I go. I'm going to do it from point A. Boom. Although my compass is not set right. I should have done that before I started this thing. What am I thinking? What am I thinking? Getting my other compass. All right. So let's keep going. Sometimes if you turn the paper instead of the compass, it makes it a little easier as well. So, all right. I want to make sure I match that line. Okay, keep going, keep going. Boom, there's a circle. They also want me to do that same circle, that same radius from point B. So I'm going to do that like so. And then I'm going to make it a little bit bigger and do it again. Okay, that goes through point B. I'm not going to do that. I'm just going to go there. Boom. Concentric circles. Circles that never intersect and have the same center, right? I'm going to do that same concentric circle from B. Boom. And notice where they intersect, right? And so there's a relationship there. And that relationship is that radius is the same distance from the point A to point B, right? They're the same distance. So what we just created is this thing called a perpendicular bisector. So perpendicular means it makes a 90-degree angle. So there it is. There's my perpendicular bisector. It makes a 90-degree angle, and bisector implies it cuts that line segment directly in half. So that is the midpoint of segment AB. And that is the point of that journey. Okay, we do not do problem 2. We're going to throw problem 3 on the board. For each polygon, for each regular polygon, the word regular implies that the polygons have the same side length. Use your compass to construct a circle with the same center as the polygon and through all the vertices of the polygon. All right, let's do it. Okay, so I'm going to go back up here, and I'm going to use my compass. Okay. And I'm going to go to the center of my polygon. This is a hexagon because it has 6 sides. I'm going to find the radius or distance to the vertice. And then I'm going to draw that circle. And if it's regular, then that circle should go through every vertice, because that radius is the same distance all the way around. And so notice that distance right there is the radius of my circle. And that distance should be the same to every vertice. So that is the circle that connects the vertices of the regular polygon. Okay, let's do this one. You got to be patient with these things. Got to be patient. Go slow. Boom. It's nice if you have a little arc to it. They tend to go smoother. So what I mean by that is, like, notice how I kind of tilt my compass as I'm drawing it, right? It's kind of like that. Always tilt it away from the pencil. Boom, gives you a nice arc. Okay, that's it. Woo, that was money. Okay, let's keep going. This is great. Okay, number 4. We don't do problem number 4. Number 5. Use a compass and a straight edge to bisect the angle. Okay, so bisect means cut it directly in half. All right, so here's how I do this process. What I do is I take my compass and I put it on my vertice B. And I'm going to make 2 arcs. The first arc I'm going to make is in segment AB. And I'm going to make the arc so that it's visible on the line segment, right? So there's that arc. And I'm going to create that arc on BC as well. So notice those distances are equal, right? The distance from B to that, distance from B to that are the same. Now I'm just going to elongate this a little bit. And I'm going to throw the point right out here and make an arc. And I'm going to throw this on the other point that is the intersection. And I'm going to throw it out there. And I just created now an equal distance away from those 2 points. And that distance right there, that arc where those 2 arcs intersect, is another point that will create a bisector of that angle. So that means that this angle and this angle are congruent because I bisected it. All right? Not bad. Not bad at all. Use a compass and a straight edge to copy segment DE. Label the image D prime, E prime. Okay, so I'm going to call that the D prime. I'm also going to go ahead and just extend a line segment. And I'm going to make it longer than DE. Now, this isn't too bad. I think you would intuitively kind of figure this out. Now, I'm going to go ahead and put my center of what would be a circle, right? That's what a compass does, is it draws circles. So that pointy end would be the center of the circle. And then the pencil end would be the shell, the outside of the circle. Okay, so I'm going to get that there. And I'm just going to notice that distance, right? Well, what do I know? That distance has to be the same as this distance. So I'm just going to make that quick little arc right there. That is the same distance. I'm going to call that E prime. If you want to make it really pretty, woo, you could erase that. Make it real nice. Look at that. Well, that's not real nice. It's good enough though, huh? Well, no, let's go for better. There we go. Okay, that's beautiful. All right. So number 7, use a compass and a straight edge to copy the angle. Okay, let's give it a go. Let's give it a go. Okay, so we need to copy that angle, right, chat? Okay, so I'm going to kind of go through the same procedures I did on the last one. So what I'm going to do is I'm going to create that point. There's that point. And then I'm going to create this line segment. So there's that line segment right there. The length of the line segment doesn't matter because remember, what I'm trying to do is recreate the angle. And this is the angle right here. All right, so now what I'm going to do is I'm going to take a straight edge, or I'm going to take my compass, and I'm going to mark right here on this angle. So I'm just going to go here and I'm going to create a mark. Boom, there and there. Okay, so I'm going to go ahead and do that. And then I'm going to create that same mark. And actually, I'm going to do like almost a third of a circle. All right, because I want to make sure that my arc of my circle goes beyond where this segment would be. Okay, now I know that this distance is the same as this distance. So if I now measure this distance using my compass, right? So now I'm going to go there. I'm going to measure that distance, create that distance here, find that intersection, and I know that if I now connect the vertice to that intersection of arcs, that I have created the same angle. I'm going to measure it. I'm going to put my protractor down, and notice that's about 68 degrees. All right, 67 degrees. Let's see what this is. Okay, and look at that. Look at that. That's about 66-ish degrees, right? So we're good. We got it. We're in good shape. All right, good job. Not bad. Construct a rhombus. Okay, so we got to know what a rhombus is, right? A rhombus is a quadrilateral. That means 4 sides. And all four sides are the same length. Okay, so that's huge. That's what we need to know. That's where we're going to work with it. So the first thing I'm going to do is I'm going to extend this ray. Well, I'll call it a line segment. I'm going to extend this line segment, okay, beyond what I think this distance would be right here. Because I know that this side length AB has got to be the same as this side length, right? I know that must be true. So now what I'm going to do is I'm going to use my compass to measure that distance. Because that's kind of what a compass does, right? It measures distances, uses radiuses to measure distances. Okay, then I'm going to take that distance, boom, and I'm going to put it right there. Now that represents the other vertice of the rhombus. Can I call that C? I'm going to call that C. Okay, so now this is still the same distance, right? It's still that side length. What do I know? I know that this side length from B to, I'll call it point D when I'm done with it, and this side length from C to D has got to be the same. So where these radiuses of these two circles intersect, that would be vertex D. Boom. Now I connect B to D. All right, yeah. And then I connect C to D. Right, yeah. That is a rhombus. Ooh, that's a pretty rhombus. A, B, C, D. All right, I like that. Okay, let's keep going. This is fun. I like constructions. I think they're fun. I hope you're enjoying it as well. Construct a square. Okay, I know what a square is. A square is a quadrilateral where all four sides are the same and all angles are 90 degrees. Woo, that's a mouthful. Okay, here we go. So I want to create square. I'm going to call it ABCD. Okay, so I want to create this square here. Sorry, you couldn't even see that because my hand was in the way. I want to create this square here, and I'm going to call it A, B, C, and D. Okay, but I got to figure out A and B. First thing I'm going to do is I'm going to say, let's extend DC. And I'm going to extend it out farther than the actual length of DC. Okay, so I'm going to extend that out. Now, I'm going to make C the midpoint of a line segment. And I'm just going to call this E. All right, so I'm going to make C the center of line segment DE. And then I'm going to create this perpendicular bisector. Perpendicular means 90 degrees. So that's what I'm going to do first. I'm going to create this leg CB. All right, so I'm going to use my compass, and here's how I'm going to do it. I'm first going to measure CD, boom, and I'm going to create that measurement here. So it's a little off on that. Little off, okay? I shouldn't have put that in there yet, actually. Okay, so I'm going to, that is E. Now notice DC and CE are congruent. They're the same length. Now I'm going to take my compass, and you got to go, to do a perpendicular bisector, you got to go beyond halfway of what you're trying to bisect. So I'm trying to bisect DE. So I got to be farther than halfway across it. Okay, so there's that right there. So as long as I'm longer than halfway the line segment I'm trying to bisect, then I'm good. I'm going to create that arc, and I'm going to create that arc right there. And notice where they intersect. Okay. Let me check something real quick. I just want to make sure that I'm good on this measurement because it looks a little off. So I'm just going to go here. I'm going to go here. Okay, no, we're good. All right, and I'm going to just real quick again, I'm going to make sure this works. I'm going to go a concentric circle, which is going to be a concentric arc, and I'm just going to make sure this gives me the same line segment, and it looks like it does. All right, so now I'm going to connect those, and this is going to be perpendicular, right? So this is perpendicular, and that was my point. This part is kind of easy because I know I'm going to do the same thing I kind of did with the line segment earlier. I'm just going to measure that line segment distance. I'm going to clean up some of this so you can see it. Okay, and then I'm going to measure that same distance here. And the reason I do that is because now that gives me point B. Right? Now I know that this distance, DC and CB, are the same. So now I got to find this point A so that it's perpendicular and the same distance as these. So what I'm going to do is I'm going to bisect angle BC. BCD. So I'm going to bisect angle BCD. So I'm going to go here, and I'm going to make a bisector. Boom. Sorry, I should have gone here. I'm going to erase this. All right, so I'm going to make an arc out here, the distance from D to out here, boom. I'm going to go the distance from B out here, boom. That point right there is the perpendicular bisector. And why that's important is because I know that A has to land on that. So A has to land on that. There's more than one way to do this. And that's the thing that's important, is there's a couple ways to construct this. So I know A has to be somewhere on that line. Now how do I find it? We'll just measure the distance, DC, because that's the side length of the square. And right, we know that side length is the same of all four sides. Got to just squeeze it slightly in. Okay, that's good. Now I'm going to take this, and I'm going to make that arc there. I'm going to make that arc there. Notice how they intersect right on that perpendicular bisector. Well, the angle bisector. It's not a perpendicular because it didn't make a 90-degree angle. And now I'm going to just draw this. Boom. I'm going to draw this. Boom. And we just created a square, ABCD. Woo, that was fun. All right, and like I said, there's a couple ways to do it. So your teacher might show you differently, and that's great. All right, let's do number 10. Use a compass in a straight edge to locate the center of rotational symmetry of an equilateral triangle. Okay, let's do it. Okay, so let's see. What do I know about the center of a polygon, a regular polygon? And what I know is that my lines of symmetry will all intersect at the center. So I'm going to create all my lines of symmetry. Remember, lines of symmetry are equal to the number of sides of a polygon. So because it's a triangle, 3 sides in a triangle, 3 lines of symmetry. So I'm going to take my compass and I'm going to bisect this angle, right? So I'm going to do the perpendicular bisector of this side right here. That's what I'm going to do. So I'm just going to take a point equal distance from here. Boom. Take a point equal distance from here. Boom. And that, where they intersect, will be the bisector of this angle down here. So that will bisect this angle, which means if it bisects that angle and goes to the center of that side, that is a perpendicular bisector of this, and it's also a bisector of this angle. It's also a line of symmetry, right? Okay. So I'm going to take this. I'm going to do it again. I'm going to do both of them on this one. So I'm going to go to this side. Boom, that distance there. I want it to be equal to this distance here. Boom, and then I'm going to do it here again. This distance here. So I'm creating my perfect lines of symmetry. Well, I don't know if they're perfect, but they're darn close. Okay, so there's that right there. I'm going to take my edge of straight. And I'm going to create that right there. Boom. I'm going to create this right here. And if I did it right, all these lines of symmetry should intersect at the same spot. And look at that. Oh my gosh. Stunning. Right there. That is the center. I'm going to call it C. And all those three lines are lines of symmetry. And the lines of symmetry in a regular polygon always intersect at the center. All right, that was fun. Okay, now we're going to do some systems of equations, right? What's the goal? The goal when you do a systems of equations is to find a point where they intersect. If I graphed that, it would be a line. If I graphed that, it would be a line. So where do they intersect? That's my goal. Notice this x right here. See how that x equals 11 plus y? Well, this x and that x represent the same number. Where they intersect, they are the same number. So whatever this x equals, that x also equals that. So I'm going to go here, and I'm going to substitute 11 plus y in for that x. Right? Because if x equals 11 plus y, then that x also equals 11 plus y. I did that to create an equation with one unknown y, because I can solve that. This is called distribution. So now I'm going to take 22 plus 2y plus y equals 19. Combine your like terms. Subtract 22. Divide by 3. And y is negative 1. If y is negative 1, I can quickly find x, because x equals 11 plus y. So x equals 11 plus negative 1. X equals 10. So my final answer is 10, comma, negative 1. And I can check it, and I suggest you do. So I'm going to go to this second equation, and I'm going to put in 10 for x, and I'm going to put in a negative 1 for y. And notice how I get out a 19, which is exactly what they said I should get out. That's exactly what they said I should get out. Okay, let's do it again. Now notice this one isn't solved for x or y, right? So there's another method. That's called the substitution method, where I took a value of x and substituted it into this one. For this one, I'm not going to do a substitution method. I'm going to do what I call an elimination method. Elimination method is where I want to get opposites in front of a variable and then add them up so that one of my terms goes to 0. So what I notice is if I multiply negative 3 by 3, that would give me negative 9, and negative 9 is the opposite of 9. So if I add that, it'll go to 0. So I'm going to take this equation, and I'm going to multiply everything by 3. That is a legal inverse operation. And then I'm just going to bring the other equation above it. Now, add them up. So negative 4 plus 3 is negative 1. So that's negative 1x. That goes to 0. That goes to negative 9. Divide by negative 1. Woo! There's x. Okay, now go to either one of your other equations, and it doesn't matter which one you go to. Just go to one of them. And so now I'm going to go to the second equation, and I'm going to let my x be 9. Subtract 9 from both sides. Divide by negative 3. There's y. So I got an x, I got a y. So my final answer is 9, comma, 5. And again, if I were you, I would just take a minute and check it. Negative 4 times 9 plus 9 times 5. And I better get 9. Woo! We did. Let's go. Let's do the next one. Okay, notice this one I'm actually going to do the same method I did before. I'm going to multiply this top equation by negative 2. Because if I multiply, by 2. Because if I multiply that by 2, 2 times 2 is 4. 4 is the opposite of negative 4. So I'm going to multiply this by 2. And that gives me 2x plus 4y equals 22. Bring the other equation underneath it. Add them up. 3x, that goes to 0, that's 24. divide by 3, x equals 8. Okay, so that's x. Now let's find y. I'm going to go to the second equation, and I'm going to let my x be 8. Subtract 8. Oh, that was tricky. Divide by -4. And reduce that fraction, please. -6 divided by -4. If it's a decimal that terminates like that, then you can use that. So I'm going to use that. I like that number. Y equals 1.5. Now, if you want to use 3 over 2, that's all right. Okay, so there's that. My final answer. I know there's a lot of work on this one, so sorry about it being a little crowded. But my goodness, there is some algebra being done here. Okay, and that's that ordered pair. Okay, let's keep going. 14. Oh, I love this problem. Notice how it's y equals and y equals. Well, if that y equals that and that y equals that, then this y also equals that, right? These two things are equal because this y and this y represent the same number. So if this number equals that and that number equals that, then these are equal. This is called the equal values method. It's one of my favorite methods. It's when you have y equals mx plus b on both equations. You set your mx plus b's equal to each other. Subtract 2x from both sides. Boom. That gives you -3x. Let's also subtract 1. Ooh, equals 0. Divide by -3. 0 is a number. Don't be scared of it now. 0 divided by -3 is 0. Okay, that's money. Because look if I put 0 in there. 0 plus 1 is 1. 2 times 0 is 0 plus 1 is 1. So y equals 1. You know what? I should have seen that before. Notice these lines have the same exact y-intercept, which means the x values must be 0 at the y-intercept. I honestly, I could have given you that answer if I looked close at it without doing any work. Anyway, good job. Let's keep going. Okay, notice how y equals this, right? So if y equals that, then this y also equals that, right? That y equals that, this y equals that. That's called substitution. So I'm going to go here to this bottom equation. Instead of y, I'm going to replace it with -2x plus 7. And that equals -8, because it still equals -8. Combine your like terms. -3 minus 2 is -5. Subtract 7 from both sides. Don't be scared. Divide by -5. Woo! There's that. Now I'm going to go right here, because I like that I can just go y equals. Put this in my calculadora, or for those people that like to use their brain. There's that. Final answer. Okay, one more to go. You've been troops. Absolute strong troops today. This has been a long video. Okay, let's keep going. Last one, people. Okay. This one's a tough one, but I can see already. If I multiply this by 2, then that's going to give me -2, and that's the opposite of +2. So that's the elimination method. So I'm going to multiply every term by 2. I'm going to bring this over. All right, add them up. Add them up. That goes to 0. That was my goal. Divide by 2. Yes. Now I'm going to find my y. I'm going to go right here to this tough equation. I'm going to finish strong. -6, not times x. Well, it is times x. But now I'm going to let x be 11. Plus 2y equals 8. Multiply those together. Woo! Add 66 to both sides. This is a big number. That's going to be a whole lot of 74. Divide by 2. And that's 37. I am suspect. I'm going to check it. I really got to check this. So I'm going to go up to this original equation right here. I'm going to put this in. I'm going to put this in. And it better equal that. I hope it does. I hope it does. For your sake, I don't want you to have to sit here and watch me do this again. Whoa, it worked. Let's go. All right, good job, people. Stay strong. Unit 1 is done. It's over. Move forward from that. This is Unit 2. It's very doable. You're going to do great. All right. See ya. Peace.